haven't seen, every formula that you've seen yet, could you show one of the windows, is implicit and is explicit. Here's another form of a function. There's an implicit function. Actually, implicit relation, but you're not really concerned about that. All that really means for you in the context of this question is isolate y when you do the inverse. So what step one do I generally like you to do first? Yeah, switch, flip. So you end up with x equals the square root of y squared plus 2y. You really don't like roots, so what are you going to do? Because what you're trying to do is isolate what? Y. So you square both sides, and you get x squared equals y squared plus 2y. I'm isolating y, so I'm going to put everything that I want to isolate on one side. Is that okay? Yeah. Sure. What are you trying to isolate? Y. You might, at this point, factor. Does it factor nicely? No. It does? Well, does it factor nicely in any way that actually gives you forward traction? No. Not really. You want to make it have one y, one instance of y. What's the problem here?
There's two separate powers.
You have you have different powers. They're non-like terms, right? Yeah. If it was like 3y and 5y, you could add them together because they would be like terms. Are these like terms? No. Here's an advanced maneuver that you have not seen, but only relies on math that you have seen. Is that legal? Yes. Yeah. If you're solving for y, what does that look like? If you're just, everybody zone in on y, just look at y, what does that look like? It's a what? It's a quadratic. What's the a value?
1.
What's the b value? And here's the killer part. What's the c value?
Negative x squared.
Negative x squared.
Really?
Bingo! You do the discriminant first. B squared minus 4ac. What is b? 2 squared minus 4 times negative x squared. So what's the discriminant? 4 minus, or 4 plus. So what does this mean? Y is equal to negative b, which was negative 2, plus or minus the square root of what? Yes? All over? 2 times 1. Yeah, 2. Let's simplify this now.
Can you explain what the discriminant is? Like,
Nope. Go back to Algebra 1. I will not go back and explain to what the discriminant is, other than to say it's the thing underneath the radical sign in the quadratic formula. That's it. Please do it first. The reason you do it first so you don't have to write this thing over and over and over again while you're just simplifying one thing. Let's actually take a look at the discriminant first here before we go any further. Can you simplify that? 4 times what?
1 plus x.
Yeah. So if you actually do this, you're looking at, if you now put in the radical, it's the square root of 4 times the square root of 1 plus x squared. What is the square root of 4? So what you can do is replace that, and you now know that y is equal to negative 2 plus or minus 2 root 1 plus x squared all over 2. What cancels? So f inverse of x is equal to what? Negative 1 plus or minus. Yeah, you got it. Excellent. It is equal to, that is correct, but it's plus or minus. If you graph this as it's written, is it a function? No, it's not a function. Plus or minus, automatically going to rule it out as a function. It's going to violate the vertical line test because every time you plug in an x value, how many y values are you going to get? 2, except for actually, nope, you're going to get 2. It's just going to be nasty. Let's take a look at, it gave us a domain to begin with. What did it give us of the original? What did it give us? So what does that mean about this function? What's the range? Nope. Y such that y is greater than 0. Right. So now we need to figure out the domain of this thing, but we need to figure out which one we want, the plus or the minus. What's one thing we could use to determine this? Maybe we could get, this is an algebraic representation, maybe we want we could start plugging in lots of values. What could plug in a lot of values for us really quickly? It's a magical device. A calculator, yeah, you could actually calculate this thing, or whatever, graph. Oh, we missed all that? Oh, that's too bad. But just remember, yeah, to get the inequality, didn't get the second part here, it's okay. Set math to get inequalities. Sorry about that. I paused it when we were graphing it. Sorry. So anyway, you have a cutoff because it's x less than 3, but that's not part of the problem, just as part of the notation for you to learn. Okay, any other questions from the home? Mean. It's mass when it's not moving. If something starts moving, what happens?
Mass.
Its mass changes. That's correct. What are also constants in here? There's one more constant. C value. The C value is a constant. It is the speed of light. Anybody remember what the speed of light is?
3
Hun-
times 10,000.
Anybody know for certain? Not just this mumbling thing. What do you got?
3 times 10, 8.
10 to the 10th?
8.
10 to the 8th?
Yeah.
3 times 10 to the 8th what?
Meters per second.
Meters per second? Sounds about right. It's 100. I think it's 186,000 kilometers per second, something like that.
Kilometers?
Kilometers per second. Anyway, but the point is, it's a constant. So m naught right here. This is pronounced m. Excuse me just a sec. It means none, not all for naught. Those are constants. What's the only variable in here? V. So you have m equals that. So what do you do first to find the inverse? V equals m naught over 1 minus m squared over. And what are you isolating now? Isolate m. So what do you do first? V times the square root. This is just algebra, kids. Equals m naught. Now what? Square what? Square root what? Yes. So what does it become on the left? V squared times 1 minus. Right now.
Divide by 1.
Yeah. Let's divide. Sure. Now what? How about we do this? 1 minus m naught squared over v squared is equal to m squared over c squared. I moved it over to the other side.
Multiply by c squared.
Multiply by c squared? Sure. What?
Would it be 1 plus?
No. C times 1 minus. It's this, right? Ooh, it's so tough.
And then take the square root.
Now what?
Take the square root.
Take the square root? We want to do that? Okay. So what do we have here? We have m is equal to the square root. What?
C squared minus C times.
Yeah, we can do that. We can multiply it in. We can do it in.
Yeah.
Shh, kids, you're all saying the same thing. There it is. Plus or minus. Plus or minus. Why? Can't have negative mass. Really fun things happen if you have the idea of negative mass. You get really cool books like Swiftly Tilting Planet and Wrinkle in Time. Negative mass. Okay, is there a way to simplify this a little bit? And it's c squared. Is there a way to simplify this?
Yeah.
Yeah, you could clean it up a little bit. Here, I'll show you the best way to clean it up. You could get c squared minus c squared m squared over b squared. You could multiply it in if you wanted to, right? If you wanted to, you could, or you could write it as m is equal to the square root of c squared times the square root of 1 minus m naught squared over v squared, right? Which is m is equal to the speed of light times. Oh, wait, no, you're totally right.
Really?
No. We're supposed to switch and solve for m. No, we're supposed to solve for m. Yeah, we're supposed to solve for m.
Switch it with V first and then solve for M.
Yeah.
You do the process backwards.
Look, no. Listen, there's not process backwards. You can either isolate and then switch, or you can switch and then isolate. Yeah, different. The other way. Yes. So yes, what did we do first? What did we do? Oh, wait, hold on. Wait, did we even switch on this?
Yeah, we did. Yeah, we did.
Oh, we did. We did. We switched right here. Yeah. Yeah. So we did switch. Yeah, we're good. We're good. Now the other class, let me just check something here. On B block, let me just check something here. We wrote it a little differently. And I got a question for you. Is this, did we get the same thing? You sure? Here's what B block got when they simplified it. Is it the same thing? I'm going to pause it here just so you can think about it for a second. Okay, any last questions from the homework? Anything else that you think is something you should have been able to do? How did, let's do that to show you where I wanted you to stop. Because this one you could do 90% of the work. Just because you couldn't finish it doesn't mean you get to skip it. Ooh. So here we go. So you wanted to know how to do this one, right? What's the one thing you would need to know how to do if you were going to finish this one? Anybody know? There's a ton you don't know. First of all, e is just a number like pi. It's an irrational number. You would need to know how to deal with, anybody know? It's the next unit. Logarithms. We haven't covered it. Some people have seen them before. One of the things you can use exponents for is to solve logarithmic equations. One of the things you can do logs for is to solve exponential equations. Have we studied either one yet? Not quite, but you can do about 90% of this. 90% of this. If you're going to find the inverse, what's the first thing you do? We like to switch, and we end up with yeah, sure. Now what? What's our goal now? What's our goal now? Isolate y. Yeah. So what do we end up with? X times 1 minus e to the y equals... Yeah, exactly. Now you can keep on going from this at this point. You can keep on going, of course. What do I do now? Distribute. Yeah, x minus x e to the y is equal to... Now what?
Subtract e to the y.
Actually, I'm just going to do this. X minus 1 is equal to x e to the y plus e to the y. I put it over on the other side instead. I just like keeping as many things positive as possible. What do I do now on the right? Yeah, what's that word called? I love factoring. Love it. Equals e to the y times... Now what? Yeah, so now you have e to the y is equal to... There it is. So that's as far as you can go with the math in this class. Now, if you knew a little bit more, which we're going to learn very shortly, you can translate this into... That's correct. Log base e of x minus 1 over x plus 1 is equal to... And on your calculator, it would look like this. ln of x minus 1 over x plus 1. You will learn about that next. But, where's the bulk of the work? Before that point. Before that point. Function? Do they give us a function? No. So we have to just graph it. Are they asking for something that's super accurate? No. So if you're going to graph the inverse, what's the first thing you should do? Graph y equals x. Let's graph y equals x. See if I can get right there. Oh, there we go. So there's y equals x.
Wouldn't you want to be going through that first point on the line with that 1, 1?
Not necessarily. Does it tell you that? No. So if that y equals x right here, you graph the, what's it called? The what? The reflection. So it looks roughly like that. So if this is f, this is f inverse. Great. So now, though, they want you to graph what? 1 over f. So to graph 1 over f, what are you going to have to do? What? No flipping. Make a? You got it. Make a table. So if x is 1, what do we think 1? Let's just make that 1, 1. Let's just make that 3, that 2. Are they asking for an exact graph here? No. So there's 4, 5. So what does it look like? 1 is going to be 1. What's 3 going to be? 3. What's 4 going to be? Approximately what? 5. And let's make this one a little higher. So let's make 5 equal to 7. Okay? Does it matter if it's super accurate? No, we're not looking for super accuracy. We're looking for approximate. You're trying to get the behavior here. 5 is what? 7. So what do we need to graph? 1 over f. So our next column is 1 over f. So what's it going to be? 1 7th, right? So if we actually graph this, if we graph this out, it's going to start there, and what's it going to do? It's going to go to 1/3, 1/4, 1/5, it's going to keep going like that. So what's this look like? Is it ever going to touch the axis? Actually, does it go beyond 5? Nope. Is there an arrow on this? Does the function continue beyond 5? Nope. Why did they have you graph these two things on the same axis? Yeah. See f inverse right there? Is that equal to 1 over f on this? No. 1 over f and f inverse graph differently. It's a good visual representation. Is it possible for the inverse in 1 over f to be the same thing?
Yeah.
I was thinking about this and trying to come up with an example, and I'm having this brain fracture. This is the kind of thing that I should have had filed away in my head, but I can't think of right now. Is there a function that where f inverse of x is equal to 1 over f of x? I'm having trouble finding it, so if you can think of one, that'd be great. 23. We had a call for 23.
Oh, yeah. Me and you got two different things.
23.
Yes.
Okay, find the formula for the inverse of the function. Okay, that's fine. We can talk about this one. So,
I think I did it in class on Friday, but the problem is when I plugged in my calculator to make sure that I'm getting the correct answer, I got,
Yeah, this one's either.
like I got for the answer, like you put it negative 30, and for x you get 10, but when you go to 10 for the inverse, you get out positive 30.
okay, let's try this here. So you get that, right? Correct?
Yeah.
Oh, it's 3, sorry.
30.
Right?
Yep.
So what do you get? 3y is equal to 10 minus x squared. So y is equal to 10 minus x squared over 3. What's the domain of this function right here? X such that x is less than or equal to what? What? Yeah, it has to be less than or equal to 10 over 3. What's the domain of this function right here? Yeah, all real numbers. So what's the range over here? Real numbers. So what's the last thing we need? We need the range of this. The range of that is going to be y what? 10/3. Okay. So you said the graph doesn't work on this? The graph doesn't work? 0. The domain here is actually y greater than 0. So therefore the domain here has to be is greater than or equal to. Thank you. So we go back to here, and so which one would it be is the real question. How do we limit this? Well, you limit it just by limiting the domain, by putting that parenthesis in, and it would graph okay.